talk about circles. Circles is by far my favorite topic. Okay, circles for me is where like all the geometry that we started to learn really comes together. So today we're only going to do like a brief introduction to circles, but when we get to that circle chapter, I get a little geeked about it because it's just so cool. All right, so today we're going to talk about some basic terms with it first. So if you want to have your notes up, the first thing is we just need to define what a circle is. So a circle is the set of all points of a given distance from a given point in the plane. Okay, so a given distance, which is our radius. Okay, so we're talking about all the points are the exact same distance away from that center. Okay, and that distance is called a radius. To name a circle, we name it according to the center. All right, so this would be called circle B. So the symbol for it is just literally a circle with a dot in it, and then the letter, capital letter, whatever the name of that point is. So that circle would be called circle B. Good? All right. Next term I want to define for you is an arc. Okay, an arc is just a part of a circle. Okay, it is the continuous distance between 2 points on a circle. And we're going to look at 3 different kinds of arcs in a second here, but I've highlighted in blue what an arc is. We have 3 types of arcs, and I've tried to color code them for you a little bit. The first type is a minor arc. Okay, a minor arc is an arc measuring between 0 and 180 degrees. Okay, so it would be more than 0, but less than 180 degrees. So for instance, here the blue right here is a minor arc. So from B to C is a minor arc. We would call this arc BC. Okay, so we put a little arc symbol above it, which I know is hard for you guys to do on your notes, but that's called arc BC. We name a minor arc with only 2 points. A major arc is going to measure more than 180, but less than 360. Okay, so that's up here in the red. Okay, that's up here in the red is the major arc. We name the major arc using 3 points. Okay, so we're going to talk about where it starts, another point along the way, and the way it ends. So that red arc will be called arc BDC, or I can reverse that and call it CDB. Okay, so minor arcs, you have to have 2 points. Major arcs, you have to have 3 points. It's like a road map. It tells you where to start, what to hit next, and where to end. Okay? The last one then is a semicircle. I have that in green up here. So a semicircle measures exactly 180 degrees. Okay, so this is do you know what this is called? EG is called? The diameter. Okay, so it's a diameter, it goes to the center. We're going to talk about that specifically in a second. But that is 180 degrees. My semicircle here is 180 degrees. We name a semicircle also with 3 points. All right, and I wrote this all out for you down below. Color coded it and everything. Questions about just naming arcs, their measures, or any of that? All right. The next thing here, we have central angles and angle measure. So a central angle is an angle whose vertex is on the center of the circle. Okay, so central, center, the vertex is on the center of the circle. So right here, BXC is called a central angle. The measure of that angle is also the measure of the arc. Okay, so the measure of that central angle defines the arc measure. So if an angle is 45 degrees, it's what's called the intercepted arc is also 45 degrees. Okay, so the intercepted arc is the arc that the angle opens up to. Okay, so like if you think about like an alligator mouth here, like here's my teeth. Okay, this is the arc it's intercepting. Does that make sense? I already just talked about that. Then the sum of all my central angles. If I were to add up all of my angles, if I added angles 1, 2, and 3 here, what do I get? 360 degrees. That means also then, because my angle measures and my arc measures are the same, that means if I add up all my arcs, it's also going to equal 360 degrees. Good? All right. So now we're going to take a second here. I want to give you a minute to look at this. So we're going to have circle E here. We're going to use circle E here to answer these questions below. So I'm giving you an arc name. I want you to classify it as major, minor, or semicircle. And then I want you to put the arc measure in there. All right, and I give you a little degree symbol. And we'll give you a couple minutes to look at that. And then we're going to go over it together. Okay, so let's go through each of our answers. So the first one is arc NKL. So because there's 3 points, I automatically know it's either going to be a major arc or a semicircle, right? So it says start to N, then goes to K, then to L. So N to K to L is that piece right there. All right, so which one is that? Semicircle. So what does that arc measure have to be? 180 degrees. Good. Okay, KL, because it has two points, what's it going to be? Minor arc. All right, so where are we? KL. All right, so KL up here starts at K, goes to L. So because this angle here, KEL is 90 degrees, my arc has to be 90 degrees. Good. How about WNL? Is that major, minor, or semicircle? Major. Okay, so it starts here at W, then goes to N, and then it ends up at L. All right, so now we got to find, right, major. Okay, so now we got to find the arc measure. So we had 90 here and 90 here, right? Because that would make a straight line. Okay, so we need to take 90 plus 90 plus 22, which gives me 202. Yep. All right, so 202 degrees. Okay, I have to scroll a little bit here. We went next, arc WL. WL is what we're looking for next. So WL is major, minor, or semicircle. That's going to be a minor arc. Okay, can we find that arc measure? Yeah. How? Yeah, 180 minus 22, right? Because we have a semicircle right here. So if I take 180, subtract 22, what do we get? 158. Good. I think there's one more down here. KNL, arc KNL. All right, so we have, where's K? Oh, there we go. K to N to L. K to N to L. Is that major arc, minor arc, or semicircle? Major arc. Okay, so now we need everything really except for this 90 degrees, right? So 360 minus 90 gives me 270 degrees. Is that okay? Is that right? Yeah. All right. All right. So now we know a little bit more about angle measures and arc measures. Let's throw some algebra into this. We want to solve for the indicated values of measures in this figure here. So we have this angle AOB is 25x, DOC is 3x, and COB is 2x. So how can I go about solving for x? Add them all up together and to equal what, though? 180 degrees. Because regardless if you're looking at angles or arcs, they would add up to be 180 degrees because they form a straight line or a semicircle. Okay? So if I take 25x plus 3x plus 2x, if I combine my like terms, I get 30x equals 180. Right? So what's x going to equal? X equals 6. So can we find the measure of angle AOD? It would be 25 times 6, or 150 degrees. Good. How about angle AOE? So we know this is 150 degrees, right? Keep in mind, look what I have right here. That's another semicircle, right? Or another linear pair, if you want to think about it that way. Okay, so what's the measure of angle AOE? 30 degrees. All right, I have a few more circle terms to talk about with you. The first one is a chord. So a chord is a segment whose endpoints lie on the circle. Okay, so it's just a segment inside of a circle. The endpoints lie on the circle. When we say on the circle, we're referring to the black line that makes the circle. Okay, when they say on the circle. Then we have a diameter. A diameter is a very specific chord. It's a very special chord. It's a chord that passes through the center of a circle. So this is a good always, sometimes never question. So a diameter is a chord. Always, sometimes, or never. Always. By definition, it's a chord. It's just a really special one, right? Can I flip-flop that? A chord is a diameter. Sometimes it is like this, right? But sometimes it's not. Sometimes it's just a plain old chord. Does that make sense? All right. The next term we have is a tangent. So a tangent is a line that intersects a circle in exactly one point. Now, you've talked about tangents before if you've had Algebra 2. I think you were talking about tangent lines intersecting intersecting a parabola. You were talking about tangents that intersect a parabola? Yes? Okay. Well, we have our tangent lines always intersect circles for us. All right? So these are circles where the tangent lines, the place where the line and the circle intersect is called the point of tangency. I believe you probably use that term. Did you use that term in algebra as well? No? Okay. So where it intersects is called the point of tangency. All right, so now I'm going to give you a chance to use some of your circle vocabulary. I'm going to give you a couple minutes to look at this. I have a figure up there on the right. I want you to name the circle. I want you to name 5 radii, 2 chords, and 1 diameter. Okay, so I have the text boxes built in here for you. I have the circle symbol already there, so you don't have to find it. And I'm going to give you a couple minutes to think. All right, so let's go through each of these. So first of all, let's name our circle. Circle C. Good. Okay, so now there are 5 radii up there. What are they? So QC, PC, OC, NC, and RC. Okay, now keep in mind, because it's a segment, I could flip-flop those, right? I could call it CQ, CP, CO, CN, CR, because they're just segments, right? Okay, good. How about, we need 2 chords. RP and where's another segment whose endpoints are on the circle? And O. All right, so again, we could flip off both of those, right? Because they're just segments. All right, then the last one is we need to name a diameter. RP, good. So RP, or PR, either way. Questions on naming the parts? All right, so your homework tonight is actually going to be a worksheet. Okay, so I'll be bringing that around to you in a second here.